All right, this next question that's labeled question 8 says that light travels at 3.0 times 10 to the 8 meters per second. The sun on average is 1.496 times 10 to the 8th kilometers from Earth. How many minutes does it take for light to travel from the sun to the Earth? Reading that seems a little bit confusing right off the bat, but let's kind of map out our problem-solving path. So we'll map this out. My answer, it asks how many minutes. When I am done, I will have minutes. It tells me that light travels at 3.0 times 10 to the 8th meters per second. That means that 3.0 times 10 to the 8th meters of distance will equal 1 second worth of time. So that's going to be the thing that takes us from distance to time, where we can switch from two things that don't seem as though they go hand in hand, right? How do you convert time to just distance? But with that fact, that's where we can make that switch. Kind of like when somebody asks us on a road trip, how far are you away? And they say an hour. How do you measure distance and time? Well, it depends on how fast you're going. And that was our velocity, 3.0 times 10 to the 8th meters per second. Then our starting point is the distance we have to cover. And so I'm going to put that as our starting point. We know that we have to travel the distance from the sun to the earth, 1.496 times 10 to the 8th kilometers. All right, my fact so far that I can use is 3.0 times 10 to the 8th meters. I'm going to have to then convert meters to kilometers at some point. It's 1 kilometer for every 1,000 regular meters. That's what that prefix kilo means. And then, so kilometers to meters, meters to seconds, and then seconds I can convert to minutes. We know that it's 60 seconds is equal to 1 minute. So now I have a path worked out. Kilometers to meters, meters to seconds, seconds to minutes. I'll multiply this up to do my converting, and then my facts that I have here to use, I will orient it so that they divide away, leaving me with just minutes. We'll put 1 kilometer on the bottom and 1,000 meters on top. Kilometers divide away. Times, let's see, what's our next step? We use that fact. And then we can multiply it by our 3.0 times 10 to the 8th meters for every 1 second. Meters divides away. Times, and then it is 60 seconds for every 1 minute. Seconds divides away. And now we're left with nothing but numbers, all the units divided away, and the only one left standing is minutes, which is what I was aiming for. I always like to go back through, make sure that my units do cancel, and then ask myself, are each of these facts true? Is it true that 1 minute is 60 seconds? Yes. Is it true that 1,000 meters is 1 kilometer? Yes. Is it true that light can cover 3.0 times 10 to the 8th meters every second? Yes, that's true. It was given to me in the problem. So as long as I carry out this calculation correctly, then I'm going to get the right answer. I also, just thinking in terms of math, there's a 10 to the 8th on the top of the fractions and a 10 to the 8th on the bottom of the fractions. To make life easier, I can divide away those 10 to the 8th values. We get 1.496 times 1,000, and that would then be divided by So you want to write it out to keep the math straight so you don't punch something in the calculator funny. 1.496 times 1,000 divided by 3.0 times 60. And I punch that in the calculator. 1.496 divided by 180, and we get, now technically this is reported as 2 sig figs. We're going to treat our conversion factors as though they all have infinite significant figures. So we'll ignore significant figures in there for right now. And we started with 4 significant figures. We'll end with 4 significant figures. That will come out to be 8.311 minutes for our answer.